Okay guys, so in this video I wanted to talk about the product law. And the product law is something that can be applied to logarithms. So I'll just write out what it states here. It states that the logarithm with the base of some number x of some number y plus the log the base of that same number x of some number z will equal a logarithm with the base of x of y times z. Okay, so this works, but we want to know why it works, right? So that's what the goal of this video will be. So first, before I start, I just want to state that any number, any number can be represented as another number to some power. Okay, let's just write v for power. Okay, v for some power. So we say number. So any number can be represented as another, or can be re-expressed as another number to some power. Okay. So some examples where we see this is 4 equals 2 squared, or 4 equals 16 to the 1/2 power, or 8 equals 2 cubed, right? And so on. So this works usually with some exceptions. So for example, 1 doesn't equal 0 to some power, right? 0 to any power will always equal 0, so 1 can never equal 0 to some power. But usually it works. So we're going to say that y equals x to some power p, and we're going to say that z is equal to x to some power q. Okay, so we don't know what those powers are. We don't know what x is, but we're able to re-express these two numbers as x to some power. Okay, so let's rewrite this equation like that. So log base of x to the p plus log with a base of x of x to the q equals log with a base of x of some number. So I'll just write number. So we don't know, I'm not going to say y times z, I'm going to prove why this equals y times z. So for now I'm just going to write number, because by the end of this video I'm going to prove that this equals y times z. Okay? Alright. So when we're taking this log with a base of x to the p, this is actually just going to evaluate to p, right? Because what a log is doing is it's trying to find what power its base needs to go to equal whatever number is in its sort of slot, right? So in this case, it would be seeing what power does x need to go to equal x to the p. Well, it actually just needs to go to the power of p. So x to the power of p equals x to the p, right? So this would just evaluate to p. Similarly, this would just be q. Okay? So this left side is p plus q. Now I want to re-express number. I want to say that number is x to the power of some number v. Okay, so this number is going to equal to x to the v. Okay, so we're just going to re-express that. So let's rewrite it. Okay, And we know this is just going to evaluate to P, and this is just going to evaluate to Q, and this is going to evaluate to V, right? So we're basically saying that V has to equal P plus Q, right? So if V equals P plus Q, right, it has to equal P plus Q, then what does x to the V have to equal? I mean that x to the V has to equal x to the power of P plus Q. And this is a rule that we've done before in a past video, but that's the same thing as saying x to the P times x to the Q. Okay, so what is x to the V? Well, it's just number. And what is x to the P? Well, it's just y, right? We just re-expressed y as x to the P, and we also re-expressed z as x to the Q. So number equals y times z. So we've just proven that this number does equal y times z. So just to recap, what we did was we re-expressed these numbers as x to the P and x to the Q. We rewrote that, and we said that these logs must evaluate to whatever the power is here, right? So if you have log with a base of that base to some power, then that will just be whatever that will evaluate to whatever the power is. So this will evaluate to P, this will evaluate to Q. And we know that the power over here always needs to equal this plus this, whatever power is over here plus whatever power is over here. So if that's true, then that means this whole number here, whatever number's in this slot, must equal whatever number's in this slot times whatever number's in this slot. So that pretty much concludes the intuition. Let's do some examples. Let's say we have log with the base of 3 of 27 plus log with a base of 3 of 9 equals log with a base of 3 of some number x. And we need to know what this power, what x is, right? So what do we know? Well, we know that x must equal 27 times 9, right? Whatever number's here times whatever number's here. So 27 times 9 equals x. And that is 263. So x will equal 263. Okay, let's do one more. Say we know that log is with a base of 3 of, 4 plus log with a base of 3, some number 5, will equal, or actually, of some number x will equal log with a base of 3 of 24. Okay, so what do we know? Well, we know that this number over here must equal this number times this number. So we know 4 times x will equal 24. So with some simple algebra, I'll just divide both sides by 4. We get x equals 6. And that pretty much concludes this video on the product law. Thank you.